In April 2016, ENEA Casaccia Research Centre has been home to a radiological and nuclear large-scale demonstration of the EDEN project. EDEN is the largest collaborative action ever funded by the European Commission to develop new technologies and solutions for preventing and responding to chemical, biological, radiological and nuclear emergencies. With an area of more than 1 square kilometre, 1,500 employees and 2 operative nuclear reactors for research, ENEA Casaccia Research Centre has been an ideal setting to test and validate the EDEN solutions to improve the response capabilities in case of a nuclear emergency. The focal points of the exercise have been the TRIGA nuclear reactor, where the simulated incident took place, the emergency response room, where decisions to mitigate the effects of the crisis were taken, and the medical centre for treatment of contaminated and injured workers. More than 100 first responders were operative during the exercise, including radiometric and medical teams and experts establishing arrangements for the implementation of protective actions within the emergency zones and beyond. The added value brought by the EDEN project was the integration in the emergency response actions of 16 different tools developed during the project. The task was to improve the decision-making process during the crisis management and to facilitate the intervention of the first responders. The innovative communication tools, EDEN Live, One-Time Message and ConfCom were used for efficient exchange of data between the emergency response room and the critical areas where the crisis was evolving. At the same time, the new systems for managing the intervention of first responders, like generic ground station and first responder kit, enabled the emergency response room to track the actions of the radiometric teams on the field and to record their absorbed dose level. A survey mission inside the nuclear reactor building was carried out by the robotic platform Prasi with a gamma-ray camera and spectrometer on board. The data was transmitted wirelessly to the emergency response room to remotely assess the contamination level inside the nuclear facility. The diffusion in the atmosphere of the contamination was simulated with RadCal, a proprietary code of ENEA. The results of the simulations were compared with real-time data acquired from ELIAS, a laser device for the standoff detection of the particulate in air. Drones with radiometric probes on board flew over the crisis area, recording the contamination level. Data was steadily transmitted to the emergency response room by wireless transfer and compared to the results of simulations. Evacuation procedures were put in place with an evacuation strategy based on the results of simulations performed with SIMP, a calculation code for simulation of crowd dynamic in chaotic situations. Finally, the structural integrity of the TRIGA nuclear reactor after the incident was assessed with a newly developed 3D laser scanner qualified to operate in the reactor vessel even under highly contaminated conditions. The exercise also included a medical part outside ENEA Research Center devoted to the treatment of severely contaminated people, and was carried out in collaboration with the Catholic University of Sacred Heart in Rome. The decontamination procedures were optimized by using Crystal, a properly developed code to support the medical staff. The added value of the EDEN solutions were evaluated at the end of the exercise during the debriefing session, where the participants also had the chance to interact with the tools providers, exchange views and share ideas. The large-scale demonstration at ENEA Research Center Casaccia has marked a significant step ahead in the adoption of cutting-edge technologies for addressing the new challenges in nuclear and radiological crisis management, and was a key moment of collaboration between technology providers and end users.